Hi, I'm Shelley. I'm a musician and researcher, and I'm going to talk about some work I've done on experimental music interfaces with WebAudio. I've never been to a JavaScript conference before, and this one has not been disappointing. So this has been really fun, and I've really enjoyed all the talks. So thanks to Dylan for inviting me. I'm really happy to be here. Yeah, this is the overview. I'm going to talk about some stuff, mostly about some projects specifically, and just to give you a bit of a background about where I'm coming from. I'm sort of deeply integrated in the live coding scene that Mina is already part of, and I think I don't need to explain live coding again. No? Okay, cool. That's good. Yeah, I've been using SuperCollider, which is an audio programming language, for like a really long time. Yeah, I've had quite a lot of time through both those things to think about what it means to get up on stage and perform with programming. So yeah, that's kind of informing a lot of what I think about. Yeah, and also through Algorave, before I started doing Algorave, I really had no idea how to make dance music. So I kind of learnt dance music through programming, which I don't know whether that was a good decision or not, but it was a decision. Yeah, but I'm kind of really interested in these sort of like fragile, like situations of like doing something really hard in front of people on stage. Whether that's coding or making dance music that you've never done before or like whatever. Yeah, I've also worked a lot in network music, so collaborating with other people over Wi-Fi or local connections. And I'm over-explaining this because I'm used to talking to music crowds who don't know about technology. So if I'm saying something that's really obvious, you'll have to forgive me for that. Yeah, and I also work a lot with data. So I had one project where I was making dance music out of protein dynamics data that they use in chemistry for drug design processes, and turning that live on stage into dance music, which was fun. Yeah, so that's something that I'm interested in as well. And I guess kind of what kind of, I suppose, like really gets me going is thinking about failure and what it means to sort of like fail through coding or fail with coding on stage and perform with these kind of like unstable and unpredictable systems. This is a performance that went very wrong, as you can tell by my facial expression. Yeah, after this performance, the event organizer said, "Oh, well, you know, crashing is just what happens in live coding," and yeah, that's true, but also something that musicians are maybe not so familiar with, because you're sort of trained to like do things like very perfectly your whole life. So sort of dealing with code in that context is maybe a more alien experience for musicians. Yeah, overall, my work is kind of about improvising with or improvising through algorithmic systems. What that means for me as a musician, and thinking about that really, and also sort of making algorithmic systems that are really hard to play with or disrupt the way that you perform in various ways, or sort of might send you somewhere that you might not have thought about if it wasn't for this system that you've chosen to interact with. Yeah, so why I got from SuperCollider, which is a language that's based on Smalltalk, to JavaScript, is because in 2018 I was part of a research project which was called Mimic, which was a project that was about making tools for machine learning and machine listening that were sort of accessible to musicians who maybe have some programming skills but aren't software developers. Yeah, I guess that was, you know, something that was more of an issue then than it is now. And so I worked on the machine listening side of this project. So machine listening is about algorithms that listen to music or other audio and try to like extract various points of data out of it. And yeah, my role was kind of making applications of that, because I'm also, you know, I'm not a software developer, I'm a musician who programs. So I was kind of like a bit of the test case of like what happens if we give this code to somebody to make some music with. So a couple of the projects that I'm going to talk about are from when I worked there, and then I'll talk about a sort of very recent project as well. So the first project I want to talk about is called Algorithmic Girl, which is really hard to say, which was my attempt to kind of think through what algorithmic punk music might look like or sound like. So Riot Girl is kind of a early 1990s punk music, which kind of came out of reaction of women in the punk scene to the misogyny of hardcore punk, which sort of emerged around the early 1990s. And the women kind of wanted to like seize the means of production and make sort of more explicitly feminist punk music that sort of spoke more to their experiences and less to like what punk had sort of turned into, which was less fun for them. So I was kind of thinking about how Algorave is got a little bit like punk music, but more modern. So Algorave has like a really strongly DIY music ethos, and also likes to experiment with dance music forms, limits, and processes. So we're typically not making like your high production value, like typical dance music that you might find in a club, but sort of trying to push limits and explore what it might mean to make dance music through code. And it's also a very human-centric technology practice. And as I said already, very much about this sort of like performative failure. Yeah, you don't really expect to get up and do like the most perfect performance, which I guess has some sort of echoes of punk. Yeah, one thing that I do find interesting from the perspective of Riot Girl and algorithms is that people always say that Algorave or live coding has got like a lot of women in it, and I mean it doesn't, but like probably more so than like lots of electronic music scenes. But because there are some fairly prominent women in the scene, people are always like, oh, there's so many women live coding, how did that happen? Well, because we worked at it, that's why it happened. But yeah, I mean, I guess there's just still some questions around whether we can call it like a truly feminist form, because we're still working within this algorithmic frame that's largely been built by men and erases a lot of the feminist history of computing, and this very male-dominated ecosystem of music technology. So I guess I was thinking a bit about like what it meant to make a very feminist art form within that context as well. Oh yeah, my slides are very up and down here. I'm just going to skip over a couple of things. This is a long, very, very long video of me failing on stage, but we don't have time, I think. Yeah, yeah, it's like 5 minutes of torture, but like I really like to play it because it's just like code theater, because like there's no music most of the time. But yeah, it's too long. Yeah, I really like this quote from the recently released Live Coding, a User Manual, which says, the human-computer interaction within live coding foregrounds a more complex, nuanced, or even entangled relation. In this case, technology is not so much put to use as a mindless production toolkit, but rather is worked with, the process unfolding through attending to or collaborating with the resistances and affordances exerted by technology, which is kind of like a really academic way of saying like live coding is about doing simple stuff and breaking things on stage. I like this quote from Coral Manton where she also talks about it's the punk end of electronic music, the best performances are where you don't know what's going to happen. You get a sense of figuring it out. So then I get to sort of like this idea of like, okay, well, I'm going to make a piece that's like about Riot Girl, and I'm going to appropriate some Riot Girl music to do that. So I wanted to kind of use Riot Girl as a sort of way of structuring algorithmic music, highlighting lack of women's voices in electronic music scenes, and as a sort of cultural provocation of some broader problematics of data bias in AI, which I don't know if we've got really time to talk about that, but essentially it's built on top of some musical machine listening algorithms. So I'm extracting data from the music, analyzing it in various ways, and then using that to sort of then structure the music. As we are probably aware, or maybe not, but this field of music information retrieval tends to prioritize like very easily quantifiable features of music, so the Western harmonic tradition. So it has a very strong bias towards like very harmonic standard forms of music, and punk music is probably not that. And many other types of music are probably not that. On top of that, like a lot of like big company AI music models essentially tend to appropriate music without sort of having any artist input into how that data is repurposed and used. That's a little bit problematic, as I think we can all agree, or hopefully. The Riot Girl was kind of a bit of a point towards these issues as a sort of like atypical and politicized input in MIR. So it's basically a corpus analysis of a database of Riot Girl music, and then I'm algorithmically remixing it through live codable search algorithms, and then a really simple interface, which I'll show you in a second, in JavaScript. And then I'm freely improvising with the results. So there's no server farms or proper machine learning in this. And also I never practiced the piece, so I kind of like wrote the boilerplate code in a couple of hours before the performance, and then performed with it. And that's kind of how I've proceeded with it since. I'll just give you a quick clip of the performance. If I just switch the display settings, I can also show you a quick demo of the JavaScript side. Oh no, I did that the wrong way around. Oh yeah, cool. So graphic design is not my forte, but this is essentially. Oh yeah, sorry. Yeah, so this is essentially the interface, and you can essentially just select audio file, and then I've got these like graphs essentially, where you each of these 4 graphs is like a different audio feature, and I'm essentially drawing a trajectory for a loop, and it's trying to grab from that file like in each for each bar, like the most the chunk of audio data from that file that most fits those 4 parameter values. And it has this like really nice bug where it takes like a really long time to load. So you get this kind of like crackling before it gets into like the loop proper. And then you can change various things like the length of the chunk that it's grabbing, and how long the whole loop itself is. Oh yeah, and you can choose like a start position in the file as well. So you might want to start at the beginning or the very end. So because it'll always take like the first most probable chunk from the file, so you can get like a different sound based on that. And it also like does this like really nice glitching thing when you change the graph, which I kind of liked because it was like kind of punky. But I mean, if I wanted it to function properly, I should probably fix that. So, oh, it's not doing it now. Oh yeah, there you go. Yeah, so typically in a performance, I would like layer up like a bunch of those windows with different files, and also have some more like beat-based stuff going on in Super Collider. So yeah, so then let's go back to the slides, and I'll talk about the second one. I have no idea how long I've talked for and how long I've got left. I've got time. How much time? I've got like a really bad habit of talking too long, so. So yeah, another interface I made during this project is called Terpsichore, named after the goddess of dance. So this is like an auto beat generator for performing at algo raves. And why? I kind of built this around the time that a long-running collaboration I had kind of died a horrible death. My collaborator tended to be the person who was like making more of the beats in the performances, and I was like, okay, well, let's just like replace my collaborator with an algorithm. Might be less annoying, we don't know. Yeah, and it was just also kind of like a way to delegate one aspect of the music making to the computer to allow me to focus, because you always have like a lot to do in live coding. It's like meant I could sort of focus on the more noisy synth stuff, which is what I really like doing. I also thought it was probably going to be better than me at making beats, because I'm not that good at making beats. Yeah, so that's why I did this. So how does it work? It's essentially generating a TSNE of beat patterns. So I give it like a database of like, I don't know how many, I think like 100 16 beat patterns. And then TS&E is like a dimension reduction algorithm. So it essentially takes them and turns them into a 2D graph. So the more similar patterns should be closer together. And from the way that I've set it up, that should mean that there should be some more gradual variation. So the actual interface itself has like a graphic view of this TS&E and like a moving marker for each set of samples. And then, there's a bunch of different parameters I can set about what that marker does. And then there's a bunch of other TS&Es that aren't visualized that control amplitude, parameters, sample variation, and I can't remember what else, but there's about 5 of them. And so, so essentially like you'll have one marker that's controlling like the bass drum samples, and it'll like move around, and whichever like point it's closest to will have a beat pattern that's associated with it, and then it's going to play the bass drum with that beat pattern. So I kind of first like made a prototype in SuperCollider, which didn't have the graphic display, but was kind of like using some sort of stochastic ways to generate random patterns. But it was actually like really hard to play with because I had to like manually make it switch between different patterns, and it was probably like taking me more brain space to use than just making beats manually myself. So that wasn't really what I wanted. This has pretty much the same as the first slide. Then I made this JavaScript version. The pattern closest to the pointer is current position is played. And then I'll show you in a second that it's got like different ways of controlling how the pointer moves. It doesn't currently have machine listening in it, but the kind of idea is that at some point I'm going to add something so that it like listens to the synthy stuff that I'm doing in SuperCollider, and that controls some of these behavior parameters. So I'm just going to go to the demo for that. So first I hit generate, and then it makes me a nice map. So each of those green circles is essentially like a marker that's moving around, and the orange one is like the selected beat pattern, and these big gray, the blue ones are like the whole graph, and then the gray one like essentially controls like the scope of the green marker. So I can make it bigger, which will give it more variation, and I can move the marker faster or slower, and then some amplitude stuff. So I'm just going to play that now. And if it's doing something I like, I can like tell it to pause, and it'll just keep doing that for like, I don't know, like 8 or 16 repetitions, I think, before it moves again. And theoretically, I can save a particular state, and then if I change things, and load that again, it should go back to that state. So I've played with it a couple of times, and it kind of works reasonably well, or well enough that I don't feel bad about not live coding the beats. Yeah. Just quickly, like the last project I wanted to show was a project called Sound Mirror, which is a collaborative project from about a month ago, so it's quite fresh. Yeah. Does anyone know what a sound mirror is? No. Okay. So a sound mirror is like a structure, these big concrete structures that they built in World War One. So it's like a massive like dish essentially that they would then put a microphone in, and they would use it for like detecting zeppelins off the coast during the war, so they could shoot them down essentially. Rob had this project where he was like, essentially it's like funded by a sort of like really big Heritage Lottery Fund project that's happening on the Tyne to Tees coast right now in the northeast of England, where they're trying to like connect people to like local heritage and the coastline and where they live. He was commissioned to do this project around the sound mirrors. So he wanted to like make a project that's sort of like ask people to like go out and record sounds and like have a way to sort of like reflect back to them back in sort of like creative ways. I'm just going to go to the demo because it's a bit easier to like show you what's going on than talk about it. So essentially what happens with this is you go to the website and you click the thing and it tells you to, of course I've forgotten to go back to, I'm still on Mirror. Okay, cool. So you click the thing, it tells you to like listen to the sounds around you. It's basically built for mobile, not for the web, so it makes more sense if you're standing outside somewhere. To interface the horizon. And then you can record like a 10-second sound clip. And then essentially it's going to take that sound clip and like add it to the already existent database of sound clips that other people have recorded, and make like a 45-second generative soundscape out of it. I'll just do that. And then it's going to load. Take some time to load. Doesn't normally take quite this long to load. This is like the classic, like you're doing a demo thing and it doesn't load. Finally. So he made this like he did like a LiDAR scan, I think, of like one of the sound mirrors, like this huge structure, and made like a point cloud model out of it, and that's essentially like interacts with the audio. So it's potentially quite quiet, I don't know. Are you getting audio? No. Okay.
If every demo is the first time at HalfStack that it ever happens. It's all good.
We were talking about fading on stage earlier, so
Yeah.
I wonder, it could be that it's just not getting my microphone actually, but it should make some other sounds anyway. Okay. Let's try that again. Yeah. Maybe when we start recording, you can all make a lot of noise for 10 seconds, and then that might help. Yeah. Okay, ready? Go. We got interactive demos. Ah. Some graphs that might be helpful. Okay, I don't know where they are, but somewhere on this website there's like essentially there's some like live. Hello. There's some like live sound level monitors that are out in the environment, in the location of where some of these sound mirrors are, like essentially like constantly recording like how loud the environmental sound is there. And that's being used to essentially process the audio, but also if you listen over headphones, it's going to spatialize it in 3D space. And it's also changing the viewpoint of the 3D model. So it's kind of like connecting through that like sort of live environmental data with this environmental sound that's been recorded, and trying to like reflect all of these things back through the artwork. And there's some pitch analysis going on as well. So like the drones are sort of like taken from the pitch content of the audio that's recorded.